There is a question in front of you. Yes, question which is written over here. A particle, there is a particle which is projected. This A particle is projected upward. This particle is being projected upward with velocity 80 meter per second. As you can see, there is a figure to understand this question. Particle is over here. This particle is projected upward with this much velocity. Velocity is 80 meter per second. Try to understand carefully. Okay. Right now, your full attention should be on this word, so that you can get more clarity without having any kind of a doubt. Here, this object is going upward with this much velocity. Velocity is 80 meter per second. I know my speed of speaking is increasing. Till here, we are crystal clear. From ground, this is ground. We are considering this surface as a ground. Over here, T is 0. Now tell me, when particle will come at ground, then at at what second particle will come at the ground over here? That is what we will find. So find when particle will come to at rest, means here. He wants to know from us that here, when particle is coming to the ground, then at what second that particle is coming? For now, can we say that V is 0? V is going to be 0? Yes, we can say. We can say it is going to be 0. We have two options. One is 80 meter per second. Acceleration is how much? Acceleration is 10 minus 10. Okay, minus 10 downward. So now tell me, in 1 second, in 1 second, how much velocity will decrease? 10. So at 1 second, this velocity will be 70. At 2 second, velocity will be 60. So at 8 second, can I say at 8 second, this velocity will become 0? This was first option. Just we can say at 1 second, velocity 10 velocity will decrease from initial velocity. Yeah. Second method is, second option is, you can use this formula. V is equal to U plus 80. So V will be as it, initial velocity is 80 plus, and here V is 0. So A is minus 10, and T we don't know. So minus 30 upon minus 10 is equal to T, 8. T is equal to 8. Here, as you can see, we wrote T is equal. At 8 second, velocity will become 0. Velocity will become 0. This. We are not talking about this, okay? This. This was another method. Now, next. Time of flight. Next is time of flight. Time of flight means in air, the particle was staying. How much time was taken by the particle when particle was in air? This is the meaning of a time of flight. Means how much time was taken just to stay in air by the particle from initial to from initial time to 8 second. This was a half displacement, you can see this half displacement. So this half and this half, this 8 second, it went till the to become velocity 0, and when it will come to the ground level, then again it will take same time, 8 second. So 8 at 16 seconds. So total time is 16 seconds. This particle took a 16 seconds to stay in air. Now third question. H max means height, maximum height. It is talking about from here to till here. This maximum height. Of course, we want the displacement from ground till the velocity where velocity is becoming zero. So what is the displacement? This is the displacement it is talking about. For this, we can use what? We can use a second equation of motion, where acceleration is not constant. Yeah, this is constant. Acceleration is constant. So we are going to use second formula, second equation. S is equal to ut plus half at square. U is an initial velocity 80. Time is time 8 plus half. A is minus 10. Multiple T is 8 raised to power 2. 2 5s are 8 8s are 64. Yeah. Plus minus 8 8s are 64. 64 5s are 5 2 32 minus 320. Okay. 640 320 minus 0 2 3 320 is a displacement from here. 320 H max height, maximum height is 320 meter. We brought this much number by using second equation of motion, because it was asking what is the displacement from ground till the velocity where velocity is 0. 320. Okay. Now velocity and location of the particle. Now velocity. I hope this three things are crystal clear for you. I want to move on. Location and velocity and location of a particle. Location and velocity of a particle at t is equal to 2, t is equal to 2, t is equal to 2, t is equal to 8, and t is equal to 10. At 2 second, at 8 second, at 10 second. What is the location and what is velocity? What is the velocity? You can easily say velocity here will be what? At 2 second. So 20 acceleration. Acceleration is at 10. So at 2 second acceleration will be 20. So 80 and here of course it is going upward. That's why velocity will decrease automatically. So 20 velocity will decrease from initial. So initial was 80 minus 20 is 60. So 60 meter per second. At 2 second velocity will be 60 meter per second. At 8 second as you can see velocity is 0. We will see hold on, we will see y. Okay, we will see y. But let me complete this v. At 10 second Add a 10 second. 10 second. So 10 multiple 10 would be 100. 100. 100. 100 minus 30. 100 minus 30 means minus 20. Minus 20 meter per second. With this much velocity, the particle will come downward. Okay, now let's see location of the particle. Location of the particle. Why? For this location, we will have to use again secant equation of motion. So that location, we want to get that where is the location of the particle at 2 second, where velocity is 60 meter per second. So you can say u is initial velocity, at multiple t is a 2 plus half multiple a is minus 10, t is a 2. 160 minus and then 10. So finally we got 150. Is it correct? Is this correct? 100. It is 60 and here minus 10. Yeah, this is correct. But hold on, this is a 2 raised to power 2. 2 raised to power 2. So this will become 20. 140. Our location of a particle is where? 100 at 140. It's a y, it's not x. Next we have 80 again multiple time is 8 plus 1 by 2 multiple isolation is minus 10, then multiple t square 8 raised to power 2. 2 5s are 8 8 is 64, 0 will be as it minus 5 multiple 8 8 is 64. 64 5s are 5 4s are 22, 6 5s are 30, 320, 640 minus 320. Now as you can see, 640, 320, 0, 2, 3, 320 again. 320. Where? So from from here to till here. Yes, this is correct. We have seen this displacement already. Now next for this y will be u is 80 multiple t is 10 plus 1 by 2 minus 10 multiple t is 10 raised to power 2. 2 5s are 10. Okay. 800 plus not plus minus 5 multiple 10 10s are 100. 800 minus 500 will be our final. 400 will be our y. This is your y answer. What are you understanding? At a 10 second, velocity is this much, and location of the particle is at 400 on along x-axis. 400 along x-axis. 400 along x-axis. This question is done. Now next question is, I'm going to erase this thing. Find displacement. Find displacement. Displacement and distance. From 0 to 10 second. From 0 to 10 second. Now question is like this. Of course, time till 10 second will be over here. At this second, what will be our velocity and what will be our, okay. Question is only asking the displacement from here to till here and the distance. You can easily find the displacement by using second equation of motion. U is 80, T is 10 plus half multiple A is minus 10, T 10 raised to power 2, 2 5s are 10, 800 minus 5, 500. So 300 is our displacement from 0 second till the 10 second. Okay, from 0 second till the 10 second. Now what about the distance? Distance from 0 second till the 10 second. Till the 10 second. Let's find this distance by using graph. We are saying this is our T and this is our V. With how much velocity? 80. This 80 meter per second. At 8 second over here, this is T is equal to 8. Velocity is becoming 0. At 8 second, velocity is becoming 0. And again, it is going over here. At 16 second, T is equal to, at 16 second, at 60 second, this velocity is going to be how much? Velocity is going to be at 16 second. Over here, velocity is 0. At 60 second, velocity will be nothing but V is equal to U plus 80, 80 plus minus 10 multiple 16, 80 minus 116, so minus 30. This will be minus 30. Minus 30. Look at why. We want this part. Where is this is our T is equal to 10 second. This is our 10 second. Okay, over here. So here tell me what will be our velocity. Here what will be our velocity? We will say velocity is going to be nothing but 10 multiple 10, 100 minus 8, minus 20, minus 20. So we want this part and this part from 0 to 8 and 8 to 10, 8 to 10, 8 to 10, 0 to 8 this part and 8 to 10 this part. So can you say this A1 plus A2? We have two triangles. So distance would be A1 plus A2, where A1 is nothing but A1 is 1 by 2, and this height is 80, and this base is 8. Base is 8 plus 1 by 2 again. Base is 2 and height is I think 20. Height is 20. Now let's simplify this. 2 4s are 8 4s are 36, 360 plus 20, 380. From here to till here, distance is total distance is 380 from t is equal to 0 till the t is equal 10 second. 10 second. Okay, this is our final answer. That is how we have solved this question. Look at this question. 300. So remember, here it would be 320. 320. Have a look for a few seconds, then try by yourself to solve this kind of equation. To find a displacement, it was easy, but when it comes to a speed, then it seems difficult, but it is not difficult once you understand it with full attention. Then let me write next question. Next. Next we have, which is same question. Okay. Now displacement in last second of upward journey. This, try to understand this sentence. What is the displacement in a last second of upward? We cannot think about this journey. No, this is going downward, and question is asking upward. So this is upward. So last from here, last will be over here. T is equal to 7. This is the last second. In this last second, what is a displacement in the last second? It means it is asking in 1 second what is going to be displacement. Ascent formula will be used. Ascent formula. So Ascent formula says uh, u plus 2n minus 1 into a u plus half u plus half 2n minus 1 into a. Let's see what will happen. So u is the initial velocity 18 1 by 2 multiple eighth minus 1 acceleration is minus 10 80 2 5s are and here 8 to the 16 15 5s are 5 5s are 25 75 so total would be 155 but I can say this is wrong, brother. Here remember one thing you can see over here. Where do you draw in this step? 80 plus. So this is minus 75. 8 to the 16, 15, 15 5s are, and now it is a 5. Now this is correct. 5 meter you can see in 1 second. Okay, this was one point. Now in the last downward journey, second is displacement in last second of downward journey. What would be? It is talking about this second from 15 to 16. From 15 to 16. Here, what is the displacement? Same formula you will use. Then after simplifying, whatever will be substituted, you substitute that value, you will get. So over here, Ascent formula. Ascent is equal to u plus 1 by 2n minus 1 and 2a. U is 80, 1 by 2 will be as it. 2 multiple n is a 16, minus 1, minus 10. 80 plus 1 by 2. So it is, this 2 is cutting, this is 10 by 5. Minus 32, 31 5s are 5 ones are 5 3s are 15 150 55 155 minus 80 5 then 7 minus 75. This is our displacement downward minus 75. Minus 75 is our displacement. It is not a distance. This is not a distance. Okay, this is your minus 75. Minus came because we have displacement. Minus came because we have displacement. This was the two things. There is a user difference between them. There is a user difference. In this question, this was asking what is the displacement in 1 second at the last 1 second, in last upward 1 second. And this second question is asking what is the displacement in last downward second, okay, in last downward second. So for this question this is your answer, for this question this is the answer. Now let's take next question. Now let's take the next question. Not next question, but topic. Topic I would say. Topic. Topic. Tell me whether we are familiar with acceleration. Acceleration, if when particle is in air, then acceleration will be equal to c. It will be equal to -10. Here acceleration is a constant. We know this point. I want to say one thing. First motion equation says v is equal to u plus at. Here we are considering this as a t naught, okay, t naught. Just your work is to replace a by z, because value of a is equal to value of z. So you can replace this a, and v is a 0. Over here v is a 0. U will be your nothing minus z t naught. Time is a t naught. We are considering this a t as a t naught, and initial velocity will be initial, okay. It will not change itself. Okay. One thing we are getting, which is t naught. T naught we are getting u upon z. U upon z. From here to till here, this is equal u by z. This is equal u by z. But as you can see, here we have double t naught. This u upon z and this u upon z, which means 2 t naught, and you can say 2 times 2u upon z. This is for full time of a flight, and this is for half t naught, half flight of half time of a flight. Okay. Now next, for displacement, let's see, not a displacement but third equation. This was the first equation of motion. Third equation of motion says that v square is equal to u square plus 2a's. Just replace this s by maximum height and a by g, that's it. So this v will become 0. V will become 0 square, u square plus 2 multiple a g and h maximum. So finally you will get how much? Minus u square upon minus 2z is equal to h maximum, okay, which means h maximum is u square upon 2z. H maximum. To calculate, you can directly use this formula, rather than using a second equation. In this you will have to substitute value of z and value of u, value of initial velocity, h maximum. So to calculate this h maximum, you can use this formula, which is u square upon 2g, u square upon 2g. Clear? So from this part you got this one thing and this another thing. From this thing you can find tan, this total tan, and from this thing you can also find z, you can also find initial velocity. From this you can calculate the total displacement from upward, from ground till the velocity where velocity is becoming zero. Where velocity is becoming zero. Just have a look for a few seconds. Now I have three figures. First figure is like this. VF is 0, initial is 60, and next we have like this, initial is 100, VF is 0, H max. Initial is 40 meter per second, H max is this much, VF is 0. What will be T? Okay, T, what will be T? Over here and over here. What will be T? And maximum height. What will be T and maximum height? Time of flight. We have to calculate time of flight and H maximum height. Look at over here. This particle is being projected with velocity of 60 meter per second. Okay. Now, in 1 second, acceleration is how much? 10 meter per second. In 2 seconds, acceleration is going to be 20. So 60 minus 20. At 2 seconds, it is going to be how much? Velocity is going to be 40. So this is 60. If you put t is equal to 6, velocity will become 0. Will velocity become 0 at 6 seconds? 6 multiple 10. 10 is the acceleration. So 10 6 is 60. 60 minus 60, yes. So so this over here, at 6 seconds velocity is becoming 0. Yeah. So this is a half 6 seconds. So complete time of flight would be 6 plus 6, 12. Same this will happen with this 100. 10 second, it will take 10 second to become velocity 0. So 10 multiple acceleration 100. Okay, 100 minus velocity 100, 0. So 0, here t is coming at 10 second, velocity is becoming 0. So 10 plus 10, 20. Here 40 at 4 second. At 4 second, velocity is becoming 0. So 4 plus 4 is equal to 8. 8 second, 8 second, 12 second. Okay. Maximum height. Maximum. As we know, to calculate maximum, we use a second equation. But here I will also use this u square upon z like this. So here it will become s displacement. Yeah, s is equal to ut plus 1 by 2 at square. U is 60, multiple t is 6 plus 1 by 2, a is minus 10, 6 raised to power 2, 36, 5 is minus 36, 0, 3, 5 3 is 15, 18, 180. 180, our answer is coming 180. So displacement from here to till here is 180. Is how much? 180. Same we will do with this. One thing I would like to tell you over here, one thing, which is, can this number come when this is used? U square upon 2z. So u is 60 raised to power 2. 2 multiple acceleration is minus 10. it is 600, and over here is 2 multiple minus 10. This will cut 18. Yes, we are getting how much? 180. Either you can use this formula or this formula. This is your choice. It's your choice. This is your choice. U square by 2z. Now over here, s is equal to ut plus half at square. U is 100, multiple t is 10, 1 by 2, a is 10, but in minus, t is 10 again, raised to power 2, 2 5 is 10. This will become 1000 minus 5, 10, 10s are 100, 100 5s are 500. So finally we got 500 as a displacement. So from here to till here, displacement would be 500. Now for this, ut plus half at square. U is 40, t is 4, half, a is minus 10, t is 4 raised to power 2. 2 5s are 4 4s are 16, minus 4 4s are 16, 80. So here displacement would be, for this question, displacement would be 80. This is how this type of equation is solved with logic. With logic. With the logic. Now let's take next question. Next is with figure. Figure is like this. Yeah. No, it this come. I know it took some minute to write question, but it is compulsory to have question. Now look at this question, brother. A particle is dropped from a tower. From a tower. A particle is being dropped from top of a tower of a height 500. So this height of this tower is 500. From here, particle is being dropped, and velocity is not being provided by anything, by anybody. Only dropping of a particle. It is asking at what second this will come to the ground, and with with how much. Here, what will be velocity of this particle when this will come, when this will hit the ground? Then what will be velocity? What will be velocity when particle will hit the ground? Time, it is asking time. Can we say that S is a 500? S is a 500. You can think one. If you are considering this downward as a positive, then upward for you would be negative. If you are considering this downward as a negative, then upward would be your positive. Okay. One thing you will have to consider. So let's consider this downward as a positive. Positive. Initial velocity will become 0. Initial velocity will become 0. This is our final velocity. Okay, final velocity. Can we calculate? No. We are able to use this formula, second equation, ut plus half a t square. U is 0, s is 500, t is we don't know t, plus 1 by 2, a is how much? So acceleration will become 10. Why 10? Because we are considering this downward as a positive, that's why. So 10 multiple t, we don't know, t square. 2 5s are 500 upon 5 is equal to 5 tens are. So t came as a 10. At 10 second, the particle will come to the ground level, okay, to the ground. This will hit at 10 second. Okay, no problem. Now what would be our this velocity? Final velocity. U plus at. U plus at. So this we are considering this V as a final velocity and U as a initial velocity. So V will be as it, U is 0, A is 10, T is 10. So this final velocity came as a 100 meter per second. This is our time is 10 second and final velocity is 100. With this much velocity, this particle will hit the ground with how much velocity? This 100 meter per second. At what second? At 10 second. It will take 10 seconds to hit the ground with a 100 velocity. Okay. So finally we have read this question. This is your answer. It was not a difficult. Again and again I am telling you, if you understand concept carefully, then question will be yours. Now next question is, here in the first right now initial velocity was 0. Now I am saying initial velocity is 30 meter per second. 30 meter per second. Initial velocity is 20 meter per second. Means the particle, somebody is providing velocity to particle. Somebody is throwing a particle with 20 meter per second. In that case, with at what second this particle will come to the ground? We can't say that at 10 seconds this particle will come. No. With this much velocity, no. Why? Because we have provided velocity, initial velocity. That's all. Everything will be same. Instead, except this your u. This your u. Now is your 500 and u will be your 20. U is your 20. Downward positive. We are considering this downward as a positive. So u is a 20. Okay. T is we don't know it. 1 by 2 multiple. A is 10. T we don't. 2 5s are okay. 500 no problem. 20 no problem. Again 5 5 is equal to t. 5 5s are 5 5s are. So 5 10s are 100 5s are. 5 2s are. It means t came as a 20. At 20 second, this particle will come. This particle will hit ground at 20 second. At 20 second. With how much velocity? You will ask with how much velocity? U plus 80. U is 20 plus is 10 multiple 20. 20 then 200. 220 with this much velocity. With this much velocity, the particle will hit the particle will hit the ground at 20 second. At 20 second. Check again. 520 t. 2 5s are 10 is the acceleration. 20 t 5 t 25. 500 by 25 2. Yes, this is correct. This is your answer. Where initial velocity was 20. Have a look. Have a look this question. Now there is a little bit change. Little bit. I would say little bit. Now question is the same that I am providing like this question. Acceleration is the same. This displacement is also same. Displacement will be 500. But initial velocity is going to be this particle from the tower, which height is 500 from the ground. So particle is being thrown with 20 meter second upward, not a downward, upward. As we know, we were considering downward as a positive, but now in this question, particle is going upward. So of course, this u will become negative. U will become negative, minus 20. It means particle is going upward. Particle is going upward. Okay, 20 meter per second. Now same formula, same equation you can use. Same equation. S is equal to u t plus 1 by 2 a t square. S is a 500. Everything will be same. Only u will be minus 20. That's it. Because we have changed question. That's why u will be minus 20. So u minus 20 and t we don't know. That's why we are using this equation. Second equation of motion. Plus 1 upon 2, a is a 10, a is a 10, and t we don't know again, we don't know. Okay, no problem. 2 5s are 500. One thing I want to tell you. What? One thing I want to tell you. Second question. U is a 20 only. Okay? U is a 20. 20 multiple t plus 1 by 2. Second question I am solving. A is a 10 multiple t raised to power 2. Hold on. 500. 2 5s are 20t plus 5t square. 5t square. Plus 5t square. Okay. Now this will be your 500. From here, this is your homework. Here, as you can see, we have a quadratic equation. Quadratic equation. 5t square plus 20t minus 500 is equal to 0. This is your quadratic equation. When you will use quadratic equation formula, then you will get exact value of t. Exact value of t. Okay. Now we have minus 20. Minus 20. 500 minus 20 t plus 5t square. Again, you have a 5t square minus 20t minus 500. This is your quadratic equation. Use quadratic formula to bring exact value of t. Exact value. So positive number will be valid. Positive will be valid. Positive number.